Back to formula and molecular weights. So, for the question, we had carbon dioxide, 1 carbon and 2 oxygens. That's going to be 12.01 plus 2 times 16 to give us a total molecular weight of about 44.01. Iron 2 chloride was a little bit different. It's an ionic compound. Recall that there's going to be 2 chlorides that go with an iron charge of plus 2. We add the 1 iron and the 2 chlorides to get 126.5 AMU total. Calculating mass percent is a simple procedure. You'll be taking the mass of your target substance, which is typically a particular element within a compound, and finding its ratio versus the total mass of the compound. This equation shows this very simple procedure. It is not provided on the AP exam, but hopefully does not need to be memorized, as it is very intuitive. You have here, in the denominator, the formula weight, or could be the molecular weight, of the compound. You have the number of atoms of the element within that compound, and then you multiply that by the element's atomic mass in atomic mass units or grams. Make sure your units are consistent between the numerator and the denominator. They should both be AMU or both be grams. Multiply that by 100% and you've got your mass percent of the element. So, for an example, let's look at ilmenite. Ilmenite is a naturally occurring ore found in the United States, Canada, Australia, Russia, and even up on the moon. It contains iron and titanium and oxygen. Now, the iron and especially the titanium are valuable metallic elements used in many products. So knowing the percent of each of those metals in the ilmenite ore is valuable knowledge, and knowing the entire percent composition is very useful for processing. Let's start with iron. We can see here that we've got exactly 1 atom of iron in 1 formula unit of this compound. We take that in the numerator multiplied by the atomic weight of iron, and we divide that by the formula weight of the entire compound. In this case, you can see here, this is iron, 47.88. That's going to be our titanium. And over here, you can see we have 3 oxygens. The subscript of 3, of course, indicates we have 3 oxygens. We multiply that by 16 AMU. Multiply that by 100%, and that gives us 36.81% iron by mass. Do the exact same thing for titanium. Again, just 1 titanium atom. You can see here again the subscript of 1 is omitted, but we know there's just 1 in there. Multiply that by its atomic weight divided by the total mass, 31.56% there. Oxygen, we have 3 oxygen atoms multiplied by 16 divided by that same total, and we have 31.64%. So then to properly show the total percent composition of this compound, we need to re-indicate that each of those add up, sum up to 100%. We see here we're actually a little over 100%. That's an okay rounding error.